Hello, everyone, and welcome to today's Energy Storage News webinar with Trina Storage, where we'll be learning about Elementa 2, which is designed as a battery storage solution to key challenges facing the industry. I'm Andy Colthorpe, editor of Energy Storage News and deputy editor-in-chief here at Solar Media, which in addition to ESN also publishes other clean energy industry sites, including PV Tech, the world's leading solar technology website. And the reason why I mentioned that is because a few years ago, my colleagues Dr. Finlay Colville and Mark Osborne came up with the term Solar Module Super League to describe some of the leading players in solar PV. The terminology caught on, and the Solar Module Super League even has its own Wikipedia page now. Among its members is Trina Solar. Trina has since then launched solar tracking solutions through Trina Tracker, and now Trina Storage is ranked as a Tier 1 energy storage provider by Bloomberg NEF, just 3 years after delivering its first Elementa project outside of China at Burwell in Cambridgeshire, England. So energy storage technology is moving fast, and leading players in the industry, like Trina, are at the forefront of making those advances happen. Current trends include a continuing move towards higher energy densities from cell to complete system level, improvements in fire detection and prevention, better design to enable faster installation, and simplifying the logistics of getting battery energy storage systems, or BESS, onto project sites and ready to be commissioned. But while the OEMs and experts researching, developing, and manufacturing the systems are perhaps leading the innovation from the technical perspective, it is actually their customers, as well as industry regulators and policymakers, who are driving the market forward. The advances in technology from cell to complete system that we'll be talking about today, in fact, come in response to the demands of those different stakeholders. They are not innovations for their own sake. In this session, Trina Storage's Head of BESS Solution Engineering, Beyond Lee, will explain the market trends driving the increasing demand for advanced BESS solutions. We'll also examine the growing complexity of battery storage applications and the markets that they can play into. Then, Beyond will talk us through Elementa 2 and how it helps the industry respond to those challenges and to the associated opportunities. Trina's strategy around solar has always been to vertically integrate production from raw materials to complete solutions, and its approach to energy storage is no different. And that makes Trina Storage experts like Beyond very well placed to discuss holistically the considerations that customers should prioritize when they are choosing an energy storage system integrator and OEM. So this session will begin with a presentation from Beyond Lee, after which Beyond and I will have a short conversation about some current energy storage industry topics and trends. As always, interaction with you, the audience, is really important to us. The speaker's presentation will be followed by an audience Q&A section, and you can put your questions for Beyond into the tab you can see on the right-hand side of your screen. We'll try to answer as many of your questions as possible, but of course we won't be able to tackle them all. The good news is that Trina Storage representatives will be happy to reach out to you and reply to any that we don't have time to cover in this session, and you can continue that conversation offline. And finally, from me, today's webinar will be recorded and made available to registrants on demand at Energy Storage News. So with that, and without further ado, I'd like to hand you over to our speaker for today, Beyond Lee. Over to you, Beyond.
Thank you, Andy, for your profound introductions. And as described just now, this is Beyond, who is the head of sales engineering of Trina Storage. And today it is with a great pleasure and honor to present regarding the topic, which is from the battery cell itself to the turnkey AC system solution integrations using Trina Storage Elementa 2 series. So today, the presentation shall be segmented into 3 parts. First, I will bring you to give you an overview into the overall market trend moving forward, and we are also to see the major challenges that was encountered for the industry. And certainly, I will also give some of the ideas regarding the exact methods we intend to solve all these challenges based on our Elementa 2 platform. So the first is a brief overview into the market trends. Yeah, as we all know, it is increasingly noticed that many of the countries are now trying to reach the carbon neutral with the countries like the United States and Europe and even and also China to trying to deliver the net zero by either 2035 to 2060. So based on such a target, we have to build up energy ecology systems surrounded by the renewable energy like the solar, wind, and more importantly the stabilizer, which we call battery energy storage systems. But now the dominant technology we are using for the stabilizer technology, which is lithium ion, to put it more exactly, which is the lithium phosphate batteries. So with this in mind, it is anticipated that the battery systems is expected to hike by more than 10-fold from 41 gigawatt-hour in 2022 to more than 540 gigawatt-hour by 2031. Yeah. So this is a remarkable growth from the battery energy storage system perspective. Yeah. So based on such a big market, we also would like to take you to see some of the challenges that are facing the industry. So the first challenge I want to give a picture is surrounding the extended waiting period for the system dispatch. For many of the system integrators, especially for those that are out of China, like the European, for example, like the European integrators, the proper approach for them is to procure the battery cells from the Chinese manufacturer, like the Cattle, like the REPT or EVE, for example. Yeah. So we in that sense, it would allow for a longer lead time for the BESS productions. What you have to do is to transport the battery cells from China to your factory production line. So as we see, it will take at least 2 months so as to make the delivery. Aside from the procrastinations of the battery cells, it also comes with other risks and losses. The battery itself shall be featured with the calendar losses or the transportation losses, which is irreversible to the battery cell itself. Also, by having the battery cells to be transported from one side to another, it also comes with some safety risks. So we have learned from some news, some reports that fire accidents could occur during the transportations of the battery cells. So, secondly, I want to talk about the integrations for the BESS productions. Sorry. Okay. The BESS systems, as we all know, it largely consists of three major components, which is battery containers, PCS units, and also the EMS systems. Considering the fact that all these key components are largely outsourced from the major suppliers, like for example, for taking the PCS example, we may consider the PCS from SMA, PE, or NGT, and the same applies to the EMS. We could consider EXS and the GPM. So, with that in mind, we have to make sure that our container systems to be compatible with the dominant brands on the market, so as to make sure that the system could be running smoothly and more effectively. This is the one point I want to mention. On the other hand, a good integration or a brilliant system integration manifests itself in two major aspects. One is the exact functions it will fulfill. Secondly is about the safety measures you should incorporate on a higher priorities. But what we see is that many of the integrators, some of the integrators hardly could incorporate the function and safeties in proper manner. The system is simply configured by having the firefighting systems, battery cells, battery packs, and the air conditioner system inside the battery container, without any further functional test and safety test. Yeah. So this could be a big issue when it comes to the site commissioning. Yeah. Moving forward, I want to also, after the battery set was fully integrated, it has to go through a variety of tests involving thereof. But what we see that some integrators are using the GB standard or the Chinese battery energy storage system standard. Why all these products are sending to the overseas countries outside of China. So rather than using the UL and IEC standards in order to make sure that the system are fully complied with the relevant standards. And also we see that some of the integrators may fail to deploy their battery system by having them to be fully tested or testing in an adequate manner, ranging from the battery cell level to the pack level, and also the container level and system, and especially the system level. Yeah, this could give rise to a number of issues when the system was transported to the site for the site commissioning, and also for the future long lifetime operation and maintenance. Yeah. After that, I want to talk a little bit about the next challenge is about the service part. For some projects, some customers who seeks to source the systems in an individual manner, which refers to an approach where the customer buys the battery container from one supplier, with the remaining components to be procured from other suppliers. So this could be faced with fragmented service windows for them. So in case of any problem incurred, they could be. The proper case is that they may file complaint to every supplier they are buying, but hardly could each supplier figure out the exact problem to solve what is happening at the site. And also we see that there's no adequate, sufficient site service personnel to help customer serve the operation and maintenance of the project. Not to mention about the spare parts to be well equipped so as to make sure that any component that fails could be replaced in a swift manner. So the next section is about how exactly how Trina from our perspective seeks to solve all this, try to solve all these challenges. Based on considering all these challenges, I would like to give a overview into our Elementa 2 platform series. This Elementa 2 is largely consists of two product series. One is the 4 MWh unit. The second is the 5 MWh high energy, even higher energy density product. As of now, these two product series has entered into the mass production stage. So we can provide this product as per your product if you have any substantial project request, and moreover, we're expected to deliver around 2 to 3 orders in the next quarter using this Elementa 2 series. This Elementa 2 is designed using Trina Storage's latest self-developed state-of-the-art of the battery cells, which could features a cycle life of up to 12K. So that means the batteries could be used up to 12 years. By having the battery container system to be with one cycle per day, and also designed based on the prefabricated ideology. It was housed in a standard 20-feet container with adequate test to be exerted, so as to make sure that the product is could reduce the static commissioning time and to be connected to the grid in a more swift manner. And also these two Elementa units with using the 4 MWh or 5 MWh can be applied to a versatile applications, ranging from the if you have the 2-hour applications, 4-hour applications, and even 6-hour applications, you can simply use these Elementa units to cater your project requirements. As we decided to have our own, to establish our own production of BESS, Trina has set in mind to build up a force-chained production facility, which means that all the critical productions, including the raw material inspections, battery cell productions, battery module assemblies, and battery container assemblies and the system level tests are all undertaken as the same production facilities or production premise. So this could allow Trina to provide our customer with a more effective and more swift productions, more deliveries of our BESS systems. Earlier this year, Trina has also launched a plan to build up the testing platforms with platforms with the aim to make sure that our Elementa 2 units to be compatible with the dominant brand on the market, which I mentioned just now. And aside from that, we will also try to test the exact functions and the safety features associated with the Elementa 2 units. So with that in mind, until this month, we have already sent 2 Elementa 5 MWh units to the United States in order to be tested and validated with the local PCS suppliers and EMS suppliers. We are expected to have our Elementa 2 units to be fully validated in order to be contribute to our customer with a more well-positioned system. Aside from the US platform, we have already sent 1 unit of 4 MWh units to Spain, which is also to be tested with PE and Siemens, and also other potential PCS supply like Team. Yeah. On the HQ side, we also have 1 single coordination facilities on the system level. We are happy to inform that we have recently accomplished coordination test with SMA's PCS units. This PCS units is procured by Trina from SMA Germany last year. So it is up until recently that we have completed the full coordination test with SMA, and which SMA I'm also told that they will also issue us a certificate regarding the compliance and high level of compatibility with their PCS units. Here's a picture showing the exact testing bed involving the PCS unit from SMA and the system, the MV unit that Trina itself integrated by itself. And also the picture that we have integrated with PE's PCS. Yeah. As for the as we try to build up our own cell production line, we considering the importance of the quality of the battery cells, we also decided to build our own testing laboratory for the battery cells. Now this battery cell laboratory has been fully established, while earning a number of certifications, like the CNAS certificate, which is a renowned authorities for the laboratory. Yeah, and also we have been accredited with the witness certification by UL and TUV SUD. Yeah. Based on all these certifications, it means that Trina Storage Cell Laboratory is well positioned to test our battery cells, so that we can produce the well qualified battery cell to our customer. Here I also want to mention a little bit of the exact the competency of the laboratory. A number of the IEC standards like the IEC 62619, IEC 62620. It's also a very important standard for the battery cells. Yeah, and also the GBT 36276, and among others, could all be implemented in our own testing laboratory. Yeah. Here's a Here's a glimpse into the testing items we have exerted or implemented onto our battery cells. Testing items like the overcharge, short circuit test, faulting, and the needle test by having the needles into the battery cell itself to see exactly the performance of the battery cells in terms of the thermal runaway. Yeah. Aside from the cell level test, I want to also give a bit of pictures regarding the system level test. We have implemented a rigorous system level test, sort of test like the IP test. We to test the protection degree of the dust and the water test that was sprouted onto the container to see its performance. Yeah, and also the test like the cycle test and the functional test. It's worth noting that Trina is now in the course of building up a thermal chamber. Unlike the one that we see, this thermal chamber can implement the high temperature and low temperature test on container level. That means we can put inside Elementa 2 a 4 MWh or 5 MWh container into this chamber in order to test and validate. This is an ideal platform for us to validate the effectiveness of our liquid cooling systems. And also to find out the exact the auxiliary consumptions so that customer can take this figure into account for relatively accurate analysis when it comes to the economic accounting. Yeah. Lastly, I want to talk a little bit about the services we have deployed. Taking Trina, we identify ourselves as not only a cell provider. More importantly, we name ourselves as a turnkey solution provider, and with that we have a full portfolio of the after sales services to be in place. Taking the UK or the European market as example, currently we have around 10 service personnel that is aimed to serve the markets like the UK and Germany, which are our primary market for Europe. And also now we have a warehousing unit with a wide range of the critical spare parts and components to be well equipped, so that the customer can be responded in a more effective manner by replacing the malfunctional components in a swift way. Okay, and also we have a training hub in Europe. Many of the customers may not have the relevant experience in this aspect, so we shall provide a full English version, a more authentic English version for the training, so that the critical ideas can be conveyed to our to our customers, site engineers. Yeah. Ultimately, the systems can be served for a long lifespan in a more stable and effective manner. That's all. Thank you. Okay.
Thank you very much, Beyond. So yeah, great presentation there, and I think talking through a lot of the challenges that many of our audience will be familiar with, and hopefully give them some ideas as to how they can overcome those challenges, but also achieve the opportunities that I think that are out there in the market. So we've got a few questions from me coming up, but in the meantime, I see that we have quite a lot of questions have come in from our audience already. So that's great. Some of these questions I think we'll actually be addressing in our discussion now, Beyond. So that's also good. But also the audience, you do have a few more minutes now, maybe about 15 minutes to put any more questions that you may have into the chat. And as I mentioned before, we will only be able to handle a few of the audience questions during this broadcast session. But Trina Storage will be very happy to reach out afterwards and discuss those in detail with the people who asked those questions. Okay, so with that out of the way, I did see actually, Beyond, there's quite a few questions about cell production in particular and whether Trina makes its own cells. And I think the answer is yes, but so what are Trina Storage's annual production capacities for battery cells, packs, and for system integration? And yeah, maybe you can give us a few more details about that, please.
Yeah, sure. As I mentioned, Trina identifies itself as a vertical integrator from the cell productions to the entire system provider. So currently, as of now, we have 3 cell production line in Chuzhou, which is our primary cell production base, with each production line coming with around 4 gigawatt-hour of annual capacity. So in totality, we can it is around 12 gigawatt-hours of battery cell productions. Moving forward, regarding the pack and the container assembly capacity, currently we also have around 12 gigawatt-hour of the capacity, so that the cell produced could be fully compatible with following activity capacities like the pack and the container assemblies. Yeah. Thank you.
Okay, great. Yeah, and I think one of the major trends that we talked about. Sorry, I'm just going to mute your microphone because we're getting a bit of echo here. But so yeah, one of the major trends we talked about is the move towards higher energy densities, and of course, Elementa 2 is an example of a high energy density solution using large format LFP lithium iron phosphate cells. So, what are your views on the increasing system level energy density, and how do you think this will evolve from a technology or market perspective, or both? And sorry, if you could just unmute your microphone there to answer.
Yeah, sure. As far as we know, we do believe that the cell capacity is on the track to be larger and larger, but there will always be limitations or the ceiling level. Yeah. The major reason that we trying to develop even larger battery cell capacity is in consideration of the factors below. Yeah. First, by having the even larger battery cells, you can build. You can integrate from your side, from our side, to be even larger energy capacity of the battery systems. As of now, what we have is a 5 megawatt unit. So by having even larger battery cell capacity format, we can build up even a 6 or 7 megawatt hour per 20 feet container. This could be amazing when it comes to cost reductions by having for one thing, the curtailment of the relevant auxiliary parts and components that was generally fitted for the battery modules. But with less modules, so the components will be less accordingly. And also, what we have been discussing these days is more about the long duration energy storage systems. I have seen energy storage news, this morning. They say that in the United States, they have quite a number of projects that involves the LDES with the duration up to 8 hours. So we do believe lithium phosphate batteries will also serve to play a role in such a application to a certain extent. So how exactly the long duration system by using our element, not element, by using the lithium phosphate, it can be simply figured out by having, for example, 1 megawatt unit or capacity of the PCS to be configured with even larger battery container, like the one I mentioned, 6 megawatt hour, 7 megawatt hour, inside one single 20 feet container. So this could give us a direct ideas regarding the potential long duration systems using the lithium ion technology should be. Some of the system integrators may use two container units to be combined with one single PCS, but this could give rise to a lot of issues, especially the loop current and the non-uniformity or the discrepancy of the performance between the battery containers. So, so this is somehow not suggested for such solutions. So that's why I would advocate the ideas for even larger capacity of the battery cells. Thank you.
Okay, that's really interesting. And of course, one other major trend that we're talking about is the improvement at the cell level in terms of performance, but also life cycles. And I've heard that Trina Storage's new 306 amp hour and 314 amp hour LFP cells offer an extended life cycle compared to other products. And perhaps you can tell us a little bit about how that's been enabled. And again, I noticed that that's a question that some members of our audience had today as well. So this would be a good one to ask, I think.
Okay. The long life cycles that was developed by Trina is largely thanks to the new technology that we have developed internally. First is the pre-lithiation of the pre-lithiation on the cathode side. So by having the cases that during the first 2 to 3 years, the degradation losses for the battery cells is relatively apparent. It's relatively quick. relatively quick, with a quite a considerable gap when it comes to the losses. So by having the pre-lithiation technology to be exerted, we can help reduce the losses of the lithium, so that it can help elongate the battery lifetime accordingly. This is the major technology we have put onto the battery cell for our 300 ampere hour plus series. The other improvement could be seen as the battery cell. We, in order to be better adapted to the pre-lithiation technology, we have also to improve the material and the features for the cathode, the anode, and as well as the electrolyte, so that it can be better adapted for the long lifespan features. Yeah, thank you.
Okay, terrific, thanks. And so you mentioned during the presentation, and yeah, this is something we've covered on Energy Storage News in the past as well, that Trina Elementa, the company, has presented 2 capacity series, and one is the 4 megawatt hour container, and the other one is 5 megawatt hours. And could you just maybe just give us a bit more of an idea, or just explain the difference between those 2 items, and maybe the different sorts of customers and projects that they might be of interest to, I guess. Oh, can you unmute there, Beyond?
Okay, sorry.
Thank you.
Yeah, sorry. The reason that we developed 2 product series, one is 4 megawatt hour, the second is 5 megawatt hour, is due to the some of the market response from our customer. The 4 megawatt hour unit is weighed around 35 tons, while the 5 megawatt unit is weighed around 42 tons. So this could pose strong limitations for some of the projects. That's why we present a 4 megawatt unit in order to cater to some of our customers' special transportation limitation requirements. This is one thing. The other thing is about 306 is Trina's long lifetime cycles. Is incorporated with our long lifetime battery system technology, or the pre-lithiation technology. So we want to. So that means the 4 megawatt unit will boast a relatively longer lifetime compared with the 5 megawatt hour container unit. As we assume, it's around 10 to 20% cycle lifetime growth when it comes to the 4 megawatt unit. Thirdly, the 4 megawatt unit shall be integrated by having all the battery interconnection cabinet into the battery container. So there will be no extra cabinet for the 4 megawatt unit. But for the 5 megawatt unit, you have to install another cabinet, a small cabinet, in order to provide the combining bus bar and also the protections on the combining side, as well as the communication functions, communication devices for the BIC for the single cabinet. So these are the 3 major differences behind the two products. Yeah. Thank you.
Okay, great. Yeah, we had quite a few questions from the audience about energy density and its and the impact that has on the weight of the containers. So again, yeah, that was a really interesting insight. We also had a few questions from the audience around the testing that you talked about. So yeah, we're just wondering, how many system testing facilities there are at the Trina Storage HQ and factory premises. What sort of testing is carried out? You did already tell us a little bit about that, but yeah, so what sort of testing is being carried out, and what can those tell you about quality and performance?
Oh, sorry. Current as of now, up until now, we have two system level coordinated testing facilities in our HQ. So we can implement a system level test involving the PCS, the and also the MV unit, and also the EMS for serving the system level test. Also, we will have also the production. Also we expected to have more testing system level testing unit in the next few quarters, which we expect to have, and based on with all these testing facilities, we can better validate, as I mentioned at the very beginning, to find out the performance of the container of the container, DC container, as well as the PCS, and the compatibility and communication between all this equipment. So customer can simply make a plug and play, and before the connection to before the full operations of the systems. Okay, thank you.
Thanks, Beyond. And I think you mentioned also, I think one interesting aspect of testing is the thermal chamber testing platform for high and low temperature tests that you talked about. And when will that be completed, and why is that an important development, do you think, for Trina Storage's production capabilities?
So, as I mentioned, currently this testing platform is still in the course of being developed and built, which we expect to have it on board by around Q4 this year. So once it was completed, we will apply this testing platform to a variety of tests. I think this for one thing, this testing platform will have a great impact on the validations of our liquid cooling or thermal simulation models that we have developed using the software. Yeah, to see exactly the temperature uniformities, the exact temperature rise for the battery containers. On the other hand, there will be some regions like the Middle East, which boast high temperature conditions. So by using this platform, we can better test and the exact performance on the high temperature conditions, like the 45 degrees, 50 degrees. In doing so, we can better adapt our liquid cooling systems and the relevant design of the inside the container, so that it can be better deployed to the Middle Eastern market, and our customer will be more than reassured to see our containers is fully tested under such a high rigorous conditions. So this is my personal ideas from this perspective. Yeah. Thank you.
Thanks, Beyond. And finally, from me, Trina Storage provides turnkey solutions to customers by collaborating with leading PCS, that's power conversion systems, and EMS, that's energy management systems brands. And you mentioned the compatibility with top brands like SMA, Ingeteam, and Sineng, and a few others. What are some interesting and important aspects of ensuring compatibility across different hardware and software platforms and manufacturers?
as I talked in the course of the webinar, we have already achieved sort of a high level of compatibility with SMA's PCS. Yeah. So what exactly the test we have conducted behind this system integrations? As of now, the overall test, the first and foremost is about the communication test. There will be some sort of communications between SMA's PCS and our BMS. The general approach from SMA side is to allow for no such connections in this background. So that's why we think it's necessary to make sure that there's some sort of connections and communications between these two units, so that it can allow for better protections in this aspect. This is one thing, and also we will test the test systems based on each of the functions or registers mentioned in the protocols, to make sure that each of the registers in the protocols can be well responded by either BMS and PCS. So this is a major work we are dedicated from the system level perspective. Secondly, we will also implementing exact function test with SMA's PCS, some sort of like the charging discharging test, charging discharging items, and also the black start, and also we will test the response time for the PCS. And as well for the system, for the entire system integration, for the entire system platforms, and other mentioned other sort of items. So with all these tests, including the communication, functional, and the safety design test that involving both the PCS and BMS, and also SMA's PPM. They call the EMS as PPM. So we can implement a better, a more well-profounded protection schemes on a system layer, on the system layer. Yeah. So our customer can be better assured about the exact performance before the Elementa 2 units can be dispatched to our customer side. Yeah, thank you.
Thanks, Beyond. And that, I think that acronym you refer to, PPM or PPC, would be Power Plant Manager or Power Plant Controller, I believe, wouldn't it? So, so we just got a few minutes, maybe about 10 minutes to answer some questions from the audience. So thanks very much to everyone who wrote in with questions. Obviously, anything we don't answer today, right now, Trina Storage will reach out to you and you can discuss. But Alexander asked whether Trina manufactures the cells by yourselves or buy them from other cell suppliers. We did already deal with that one. Trina Solar manufactures the cells. But also Alexander asks about the 12,000 cycle life of the cells. Does that refer to full cycling from 0 to 100% depth of discharge?
Oh, sorry for missing. Exactly. The life cycle test on the cell level is implemented in a way that considers 100% of COD based on 0.5 P. 5P rate, or even some circumstances, we even put the 300 anti-hour battery cells to be tested based on 1C rate. Yeah.
Sorry, Bjorn. I think your internet signals dropped out a little bit there. We couldn't really hear your answer properly. Is that? Do you have a hotspot or something you could?
Okay, sure. Try the switch.
Okay, please bear with us for 1 second, folks. Hopefully beyond will be back with us.
Okay, so you can hear me now?
Not really. Could you try rejoining really quickly?
Okay, sure.
Yeah. Okay, we're very sorry about this, folks. We will have Beyond back with you. Unfortunately, these things do occasionally happen. I believe Beyond is actually, working from near a customer site at the moment. So that's exciting to see. Obviously, that Trina Storage is around the world talking to customers and discussing new projects and new technologies. But obviously, the downside of that, unfortunately, is that I think he's dealing with an unfamiliar internet connection. So he'll be back with us very, very shortly. In fact, here he is. Hi, Beyond.
Hi. Sorry for the interruptions. Yeah, internet interruptions.
No problem. That sounds much better. So, if you wouldn't mind just talking us through the the 12,000 cycle warranted cycle life of the cells. Could you just tell us a little bit about that, please?
Yeah, sure. As for the 12K cycle life, the exact testing conditions associated with the test is implemented, having taken into account the fact the case that the cell is tested based on 100% DoD, while considering the 0.5 P for the charge and discharge rate. And yeah, this is as of now we have implemented around multiple K around 1,000 cycles for our 314 14 ampere hour battery cells and 306 ampere hour cells, and hopefully we will see more productive data from the battery cell as we test moving forward. Yeah.
That's great. Thanks, Beyond. So I'm going to try and ask these two questions together so we get through some more of these because we haven't got much time. So be ready. So Konstantin asks, what's the energy content of the modules used in Elementa 2? And then also Matteo asks, are you thinking about integrating string inverters inside the Elementa 2? So if you could talk about the energy content of the modules in Elementa 2, and then the thinking behind central versus string power electronics.
Okay. The energy content. As for this point that was concerned, the Elementa 2 is featured with two energy capacity. One is 4 MWh, the second is 5 MWh. So does he want to see this point, or am I understand incorrectly? If not, please help rectify. Thank you. And as for the point from one of the audience saying that whether the string level PCS can be incorporated into our container. As a matter of fact, we do in the course of the developing some sort of string level solutions. We do think these solutions could be a great could serve to playing a great part when it comes to the long duration energy storage systems. I think, and you know why? The string PCS or or the string level DC-DC converters can particularly come in handy when it comes to a case where one PCS unit was connected with a large number units of racks of the units of battery racks. So this could give rise to a variety of issues. For one thing, this is about the short circuit current for all these battery racks. You have to see a way in limiting the entire battery rack current or short circuit current. Also, there could be a case where the loop current could also be considered as a problem for the entire systems. Not to mention, more importantly, with so many battery racks to be connected, there could be especially a particular problem. The difference, the gap, the voltage gap between each battery rack. So this rack level solutions or the solution using the string level PCS could be a brilliant solution behind this. Yeah.
Okay.
I'm not sure. Yeah. Yeah. That's what I share from my perspective. Yeah.
Okay, excellent. Thanks very much, Bjorn. Let's just do maybe one or two. Oh, you okay there?
Okay.
We'll just do one or two more quick questions, and we'll call it the finish for today.
Okay.
We actually had one topic that I was surprised, I guess, or maybe not surprised, but one topic that is quite recently emerged in the UK market, which one of our audience was asking about, is noise emissions from BESS containers. So we have someone asking for a noise test report from Elementa 2. Obviously, that's something we can't provide during this webinar, but it's something that Trina Storage can talk to you about there to our audience member Taha. But also, Tariq asks, on the noise test in the chamber, to what standard was this tested, and how does this compare to Elementa 1? So noise emissions, I guess, from Elementa 1 and 2.
Yeah, a noise level indeed is considered as a critical point that many of the IPP developers would raise. Yeah. For the Elementa 1 units, this would not be an issue, as the noise level is absolutely controlled within the stipulated regulations. But for the Elementa 2, especially for the Elementa 2 5 megawatt unit, it applies with 60 kilowatt hours of liquid cooling chiller, so that could make a great sense when it comes to the noise emissions. Yeah. We are now on the one hand coordinating with liquid cooling suppliers in help optimizing the noise levels on the one hand. On the other hand, we can share some of the insights. Some of the okay. On the other hand, we should rely on some sort of the external devices to be added so as to help reduce the overall noise levels. And so in order to validate what exactly whether the external noise external device would work with the Elementa 2, we are now in the course of planning we are now building up the testing platform for Elementa 2 units, with also the PCS and the EMS. When there's any further update, I will let you know.
Okay, that's fantastic. Thank you very much, Bjorn. So Lots more great questions came in, but unfortunately, that is all we have time for in today's session. So I really want to thank everyone who registered and joined. You will be sent the presentation slides afterwards, I believe, as well. And if you want, you can watch this session again on demand on the website in the coming days. Yeah, so I really want to thank Beyond for sharing his expertise with us and sharing some exciting developments from Trina Storage there. But most of all, yeah, would love to thank all of our audience for joining, and not just for joining, but for being part of this this fantastic industry. And we appreciate all the really hard work that you do. And as I said before, if you did ask a question and we didn't have time to answer it, Trina Storage will be reaching out to you to get in touch. And of course, you can always go to the Trina Storage website. The details are on the screen right now to find out more. So bless you, Beyond. I hope you're well. Hope you're well anyway. And thank you so much for joining us. And yeah, hopefully see you soon as well. It's been a pleasure.